For what reason do Earth and the different planets revolve at all? Written by Shahzad Qureshi. The article was posted in bloggertown.com community, in Science and Technology category. Perhaps the most surprising highlights of our planetary system are that essentially the entirety of the revolutions and rotations are similar. From a dot tall above the north pole of the planetary structure, the spheres are spinning around the Sun and rotating over their tomahawks in an anticlockwise way. This remains constant likewise for the asteroids. In the event that the planets and asteroids were shaped from just arbitrary accumulations, there must be an even combination of the bearings of revolution and rotation. The Sun itself additionally rotates on a counterclockwise track. The satellites of the planets, furthermore by and large, spin and rotate in a counterclockwise manner. Of the 30-something satellites, just 6 don't do as such, they are claimed to have retrograde motion. Of the 6 special cases, 5 are external satellites prone to be caught asteroids. Understanding retrograde and prograde motion. The retrograde movement in space science is from the large, orbital, or rotational movement of an article toward the path inverse to the rotation of its prime, that is, the fundamental object. It might likewise depict different movements, for example, nutation or precession of an object's rotational axis. Whereas a prograde or direct movement is a more typical movement similar to the primary rotates. Nonetheless, retrograde and prograde can likewise allude to an article other than the principle if so depicted. The course of rotation is accentuated via an inertial term of reference, like distant static stars. In the heliocentric structure, the orbits around the Sun of each planet, and generally different articles, aside from numerous comets, are being prograde, for example, in a similar way like the Sun spins. Apart from Venus and Uranus, planetary revolutions are likewise prograde. Mainly regular satellites encompass prograde orbits around their planets. The prograde satellites of Uranus orbit toward the path Uranus spins, which is retrograde to the Sun. Essentially all customary satellites are tidally sealed and, in this way, have a prograde revolution. Whilst retrograde satellites are usually little and far off from their pertinent planets, with the exception of Neptune's satellite Triton, which is enormous and close. The entirely retrograde satellites are believed to be shaped independently, prior to being caught by their planets. The majority of low-tendency artificial satellites of Earth have been set in a prograde orbit. In light of the fact that in this stateless propulsion is needed to arrive at the orbit, when dispatching in a prograde bearing. For what reason do Earth and the different planets revolve at all? It will assist with seeing how our planetary system is framed. Very nearly 5 billion years back, our planetary group had its openings in a huge cloud of dust and gas. The cloud started to fall, crashing into a massive disk that turned quicker and quicker, similarly as an ice skater turns quicker as she gets her arms in. The Sun framed at the middle, and the whirling gas and dust and the remainder of the turning plate amassed together to fabricate the moons, planets, asteroids, and comets. The cause too many items circle the Sun in almost a similar plane, named the ecliptic, and in a similar route is that they are all shaped from this equivalent plate. As the planets were shaping, there was minimal harmony in our planetary group. Clusters of matter of all sizes frequently impacted and either stayed together or sideswiped one another, breaking down pieces and directing each other in turn. Occasionally the gravity of enormous items would catch tinier ones in a circle. This could mean the planets procured their moons. What do scientists presume? Scientists feel that an enormous object, maybe the size of Mars, affected our young planet, taking out a lump of material that, in the end, turned into our moon. This crash set Earth turning at a quick rate. Researchers gauged that an average day for early Earth was distinctly around 6 hours in length. The moon shaped a lot nearer to Earth than it is nowadays. As Earth revolves, the moon's gravity makes the seas appear to rise and fall. The Sun additionally does this, however, not so much. There is a smidgen of grinding between the tides and the spinning Earth, making the revolution hold up only a tad. As the Earth eases back, it allows the moon to crawl away. We can utilize incredibly precise atomic clocks to quantify exactly how much the revolution is slowing up. 100 years from today, the day will be around 2 milliseconds lengthier than currently. 2 milliseconds is 1/500th of a second, or how long it requires for a vehicle going 55 miles per hour traveling just 2 inches. At the end of the day, significantly less than the squint of an eye. Thus, in case that you live to be 100, you can't say anything negative that the days are getting smaller. Going on like this, however, you don't need to stress over the days getting sufficiently longer to alter things definitely. Thank you for listening to bloggertown.com community article.